In the vast theatre of space, sometimes the most compelling stories are told not by what we see, but by what we don't. This is the story of 3IATLAS, the third interstellar visitor we've ever confirmed, and the mystery of its missing pictures. By late October 2025, a fleet of solar observatories, SOHO, Stereo A, the Parker Solar Probe, and even orbiters around Mars, all had a front-row seat as this cosmic traveler passed behind the Sun. Yet, as we speak, NASA's public archives remain empty. Not a single image has been released. This silence has fueled speculation online. Is something being hidden? Is there a secret? The truth is far more fascinating, and it lies in the meticulous, painstaking process of turning raw data into scientific knowledge. It's not a conspiracy. It's calibration. When an object like a faint comet gets close to the Sun, it's like trying to spot a firefly in a searchlight. Ground-based telescopes are blinded by the Sun's glare. The job then falls to specialized spacecraft coronagraphs, instruments designed to study the Sun's corona, not faint, fast-moving comets. They're flooded with light, hot plasma, and cosmic rays. Finding a magnitude 14 comet in that storm of photons is a monumental task. So yes, NASA has the data. The Parker Solar Probe's whisper camera almost certainly recorded it. But that data isn't a collection of JPEGs ready to post. It arrives as enormous packets of raw telemetry, compressed, scrambled, and needing to be painstakingly reconstructed. Engineers must correct for instrument errors, filter out noise, and align everything with the spacecraft's exact position and the comet's ever-changing path. They are essentially building the image from scratch, one data point at a time. The reason you haven't seen the images is because, in a very real sense, the images don't exist yet. They are still just ones and zeros waiting to be translated. This is standard practice. NASA operates on a strict data release hierarchy. First, there's Level 0 data, the raw telemetry. Then Level 1, calibrated but full of artifacts. Level 2 is science-quality data. And finally, Level 3, the polished, validated products that make their way to the public. Moving from one level to the next can take months of careful work by dedicated teams. What some call hiding footage is actually the methodical journey from Level 1 to Level 3. Why all the fuss? Because with an object this extraordinary, precision is everything. Every single pixel matters. Prematurely releasing uncalibrated images could lead to wildly inaccurate conclusions about the comet's path and composition. The most exciting question about 3IATLAS is whether its trajectory deviated from predictions. Early reports hinted at a shift of nearly 1 million kilometers. This could be a sign of massive outgassing, jets of gas and dust pushing the comet off course, or it could just be an error. To find out, scientists need perfectly calibrated data. Releasing anything less would be scientifically irresponsible. Think of it like this. A single corrupted frame could throw off the entire calculation, leading us to believe something that isn't true. For example, to understand the comet's outgassing thrust, scientists need to measure the faint glow of its coma against the solar background. That requires perfectly flat-fielded, dark-subtracted, radiometrically corrected imagery. It's not about making a pretty picture. It's about getting the numbers right. This isn't the first time we've seen this. Remember 2I Borisov and the famous 1I Oumuamua? In both cases, data was held back for calibration. With Oumuamua, we never even got a clear image, just light curves and trajectory data. The real story of 3IATLAS will likely unfold in the same way. Not through dramatic photos, but through graphs and figures showing its non-gravitational acceleration and chemical makeup. There's also international coordination. NASA and the European Space Agency often collaborate, and their data must be cross-calibrated to ensure everyone is on the same page. This adds another layer of review, but it guarantees that the final result is robust and trustworthy. Ultimately, the delay in seeing 3IATLAS isn't about secrecy, it's about scientific integrity. In an age of instant information, it's easy to mistake patience for concealment. But in astrophysics, extraordinary claims require extraordinary calibration. Scientists want to be sure, down to the last photon, before they announce a discovery. So, when will we see it? The images will likely appear quietly, not with a big press conference, but on a NASA data server, accompanied by detailed notes. Researchers around the world will then download them, test their models, and finally, the silence will break. Not because a policy changed, but because the science has been verified. The comet itself is already gone, fading back into the interstellar dark. But the data it left behind is a precious gift. The patient work of science is now underway, turning that raw data into understanding. It's not secrecy, it's the disciplined, beautiful process of learning to see the universe clearly, without deceiving ourselves. Thank you so much for watching. If you found this explanation helpful, please consider liking this video and subscribing to the channel for more deep dives into the cosmos. See you next time.